Welcome to this video, guys. I'm going to be talking today about adding and subtracting algebraic fractions. Now, you might be thinking horror fractions, horror algebra with fractions, but fortunately, all of the techniques that you've used to solve non-algebraic fractions are totally usable, completely useful in solving algebraic ones, okay? So we'll just run over a couple of things with generic fractions, and we'll move on to mainly examples, because you've seen fractions being added and subtracted before. All we're really doing is applying a bit of our understandings already with algebra to that. Okay? Right. So first off, a couple of things to know is that remember that fractions cannot be added or subtracted unless they have a common denominator. Okay? So remember with a normal fraction, if it was 3 over 2 plus 5 over 7, we can't carry that out. Okay, they have not the same denominator, so we can't do it. If it was instead 3 over 2 plus 5 over 2, we could, because we just add those together and get 8 over 2, and which is equal to 4. Okay, please remember that if the denominators are not the same, you cannot add or subtract them. Okay, very, very important. However, as we sort of see here, if two fractions do not have a common denominator, you must create equivalent fractions with the lowest common denominator. Okay. Now, hopefully you've had plenty of practice that with fractions before, with just regular fractions, and we're just going to kind of integrate it in with our algebraic fractions, okay, rather than cover it again separately. So let's move on to a couple of worked examples. All right. First off, here we have 5x plus 5x over 6 plus 7x over 6. Okay, now first thing you ask yourself, are the denominators the same? So we have same denominators. So just add the numerators. Okay, so all we need to do is 5x over 6 plus 7x over 6 is equal to, now remember we keep our denominator the same. Okay, our denominator is the same. Okay, if it's 6's here, it's 6 here. Then on the numerator, we're just adding our numerators together, so we'll get 5x plus 7x. Now, if we're doing this properly, we need to think about, can we add these two together? Can we carry out this addition? Well, let's have a look. These two things here, they are, remembering, they are what we call like terms. So, yes, we can add them together. So we simply add the coefficients, and we'll get 5 plus 7 is 12x over 6, and we can simplify that. Always simplify your fractions if you can. 12 divided by 6 is 2x. Okay, so that's a fairly simple example. Our denominators were the same, so we just kind of went through the process. Alright, here's another example here. We're going to have a look at 4b over 3 plus 2b over 7. Okay, so here we have different denominators. So the first thing we need to do is find the lowest common multiple of the denominators, okay, of 3 and 7. Okay, so lowest common multiple of 3 and 7. Remember, the sort of quick way to do it, I suggest, is 3 and 7, multiply them a couple of times. So 3 times 2 is 6, 9, 12, 15, 18, 21. 7, 14, 21. Ah, there we go. Okay, it's 21. Okay, now, also, because they're both prime numbers, you probably could have just multiplied them together. And that also works too for anything, whether they're primes or not, but you need to be careful about whether you have to simplify it afterwards, okay? Right, so we've got our last common multiple of 3 and 7 is 21. So, we will rewrite our fraction. So I might move it over here. Oh, no, I'll just do it here. Right, 4b over 3 plus 2b over 7. Now, what are we doing to this 3 to make it 21? We're timesing by 7. We're timesing this one by 3. So that means this top one needs to be times by 7. This top one here needs to be times by 3. Because remember, we are making equivalent fractions. To make an equivalent fraction, you multiply the numerator and the denominator by the same number. Okay, that is how you make equivalent fractions. So we will now rewrite this as, well, 4 times 7 is 28b over 21 plus 6b over 21. Now that we have the same numerators, we can carry out the addition. Okay, so same numerators. Now we just simply do the addition, and we'll carry that out. So we have 28 plus 6 is not 20, it is 34. 34b over 21. Okay, can we simplify? Can we simplify? Well, I don't think so. 34 is an even number, so 2 is not going to work with 21. 3 or 7 isn't a factor of 34, so I just leave it. Okay, right. Let's go down to this next one. We have subtraction. So again, we have a look at this. So we have different denominators. Different denominators. So we need to first find the LCM of 5 and 30. Now, again, here is where it is very handy if you know your times tables well, because you will know that 5 itself is a factor of 30, and 30 is obviously then a multiple of 5. So we only need to change one of these fractions. So only the first one needs to be turned into an equivalent fraction. And I'll show you how that will work. We have 6j over 5 minus 11j over 30. Okay, sort of the point I'm making here, the LCM of 5 and 30 is 30. So we only need to, so 5 times 6 is 30. So we're going to multiply this by 6, and then we also need to multiply the numerator by 6. Because remember, that's how you create equivalent fractions. Multiply numerator and denominator by the same number. Right, we'll rewrite it. So we have our new denominator of 30. And I have 6 times 6 is 36j minus 11j. 36 take 11 is 25, so I have 25j over 30. Can we simplify this? So, can we simplify? Yes, we can. The highest common factor of 25 and 30. Well, we're asking ourselves about that, and if you're sort of on the ball, you will recognize straight away that it's going to be 5. Okay, because both of these are divisible by 5. We have a number that finishes with a 5, a number that finishes with a 0. So 5 is probably a good one to try first off. So 25 divided by 5 is 5. J over 30 divided by 5 is 6. Okay, and so 5j over 6 is our fully simplified fraction in the end. Okay, our last example for today. Right, we have x over 4 take b over 9. Now, both of these fractions have different denominators and different variables, but the main thing we're worried about is the fact that we have different denominators. That's the main concern. So, the LCM of 4 and 9 is, if we have, well, 4, 9, do our little table up. 9, 18, 27, 36. Hopefully it's jogging your memory that this is going to go 4, 8, 12, 16, 20, 24, 28, 32, 36. So our lowest common multiple of 4 and 9 is 36. Again, that's the kind of stuff you'll start to recognize and know as you go through, rather than have to sort of do out these tables all the time. Okay, so we have x squared over 4, take b over 9, and we're going to multiply this by 9, multiply this by 9, we're going to multiply this by 4, multiply this by 4, because remember, we're trying to create equivalent fractions with the same denominator, and we will end up with 9x squared take 4b over 36. Okay, now when we look at this, you might think to yourself, okay, can I take these two things away? Can I carry out this subtraction? No. Why? Well, the simple answer is because these are not like terms. Not like terms. Okay, so you cannot subtract them. Don't do it. Don't even think about doing it. It is not something that you can carry out. Okay, that's probably one of the biggest traps that will happen for you early on in algebra, is that you'll try and do too much to things that you aren't able to change. Okay, so I hope this video made sense. I hope it hasn't scared you too much that fractions are coming back in, but I promise you that it will be okay. They're exactly the same as they were before, and in fact this might give you a bit more practice on making sure fractions, you are fine with dealing with fractions. Okay, thanks for watching. Maybe have a go at some of the questions, otherwise bring extra questions and concerns to class and we'll deal with them then. Thank you.